Hello guys, in this video we are going to study about the respiratory volumes and capacity with the help of this simple diagram. So we have 4 volumes and 5 capacities. First we will study about the volumes and then we will study about the capacities. So let's begin. Imagine this full diagram as the lung volumes. So the first is the volume is the tidal volume. This is the volume of air inspired or expired during a normal respiration, that is without any exertion. So this is the normal volume of air that is expired or inspired during a normal respiration. So it is around 500 ml. Then we'll move to inspiratory reserve volume. As the name itself is saying that it is a reserve volume that is not normally used. It is used during forceful inspiration, like when we are exercising. So it is the additional volume of air. So point is additional. It is the additional volume of air a person inspire by a forcible inspiration. So it is additional. So tidal volume is not included in it. So the air which we inspire above this tidal volume is the inspiratory reserve volume. So it is normally 2500 to 300 ml. Similarly, we have expiratory reserve volume. It is also the additional volume of air which a person expire during a forcible expiration. It is on an average 1000 to 1100 ml. The last volume is the residual volume. It's also itself saying that it is the residual volume, that is the air which cannot be removed from the lung by any means. So you can use any force, you cannot expel this air. So it is the volume of air which cannot be removed after a forcible expiration. So it is on an average 1100 to 1200 ml. We are done with the 4 volumes. Now we'll move to the capacities. So capacities are by adding few of these respiratory volumes. So first of all, we'll begin with the inspiratory capacity. It is a total volume of air a person can inspire after a forcible expiration. So after a forcible expiration, the lung volume is this much. When a person starts inspiring, first of all, he will take the tidal volume, and he will then, if the person applies the force, then it will inhale the inspiratory reserve volume. So the inspiratory capacity comprises of tidal volume and the inspiratory reserve volume. So it will formulate the inspiratory capacity. Similarly, the expiratory capacity is the total volume of air which a person can expire after a normal inspiration. After a normal inspiration, the lung volume is at this point. So when person starts expiring, first of all, he will remove the tidal volume, and then when it applies the force, then it will exhale the expiratory reserve volume. So expiratory capacity comprises of tidal volume and the expiratory reserve volume. Next capacity in line is functional residual capacity. It is the volume of air that will remain in lung after a normal expiration. After a normal expiration, the lung volume is this much. So the air which remains in the lung after a after a normal expiration. So we have expiratory reserve volume and the residual volume. This will comprise of functional residual capacity, ERV plus RV. Then we have vital capacity. Vital capacity is a maximum volume of air a person can breathe in after a forcible expiration. After a forcible expiration, we are at this point. Forcible expiration means person have removed tidal volume as well as expiratory reserve volume is removed by the patient. Only the residual volume will be remaining in the lung. So after a forceful expiration, when a person starts inspiring, it will inhale first of all expiratory reserve volume, then it will take tidal volume, and when person applies force, then it will inhale the inspiratory reserve volume. So these three capacities comprises of vital capacity. So vital capacity is tidal volume plus inspiratory reserve volume plus expiratory reserve volume. And the last in line is the total lung capacity. Total lung capacity is the total volume of air accommodated in the lung at the end of forced inspiration. When we fill our lung fully with the air, so we are at this point. So this much capacity is the total lung capacity. So it will comprises of inspiratory reserve volume, tidal volume, expiratory reserve volume, and the residual capacity. So this is the formula of total lung capacity, and we can also reformulate this formula as residual volume plus vital capacity, because vital capacity is ERV plus tidal volume plus inspiratory reserve volume. So these are very important MCQs which are easily framed. So as we moving ahead, we have an instrument called spirometer which is used for clinical assessment of pulmonary function. So the volumes which cannot be exhaled, which cannot be exhaled, cannot be measured by the instrument, so we cannot measure residual volume, and the capacities which contain residual volume in equation also cannot measure this tidal measured by this instrument. So our spirometer cannot measure residual volume and FRC, functional residual capacity, and total lung capacities. And the last very important point is, what is minute ventilation? Minute ventilation is the amount of air inspired or expired in 1 minute. So the formula of minute volume is tidal volume into respiratory rate. So our tidal volume is 500 and the respiratory rate on an average is 12 to 16 times per minute. So it will becomes 6000 to 8000 ml per minute. Examiner can confuse ml with liter, so be careful. And if you like my video, kindly like, share and subscribe my channel. Thank you.